I just want to write on the board how it is in the book. Now, just before we do this, what I want to show you is how they write it in the formula book. That is the same, except instead of using F and G, they use U and V. So, you know my formula is like this: F G derivative minus integrate F G derivative, no, F derivative G.
F G, not F G derivative.
Oh, sorry, I was confused with the question. Fg minus integrate F derivative G, like this. And this is for when you have integrating F, dx here, huh? This is when you're integrating Fg derivative dx. Now, the way they have it in the book is like this. They have u dv dx equals uv minus integrate du dx v dx. Now, if instead of writing dv dx, I wrote v with a little dash, it would look like this: integrate u v dash, v derivative dx equals uv minus, and what would this be? U dash v dx. Now, can you spot how that is exactly the same as what I'm using in class? The only difference is I got into the habit of using F and G. I don't know why, but in the formula book they use U and V, but it doesn't matter. It's exactly the same formula, just U and V instead of F and G. So would you prefer if I keep using F and G, or would you prefer, okay, not to switch to U and V then? Okay. Right, so that's in the formula book, that formula. Right, so let's have a look at that question then. You want to integrate 3x sine 4x. Yeah. Okay. Right, so this one here, this is our f, and this is our g derivative. We'll make our table. F derivative, g derivative. So this will be 3x, so this will be 3. And this one here is sine 4x. And does anyone know what this one will be? Almost, but not quite. So let's calculate on the side. I'll go back to it in a moment. You want the antiderivative of sine 4x. Now, you don't actually know how to do that. You only know how to do sine x. What's the antiderivative of sine x? Minus cos x. But how could you calculate this? What could you do to calculate it? Maybe we could use a method you learned recently? Oh dear. You could do this. So what does du dx equal? 4. So dx equals du over 4. So this now becomes sine u du over 4, which is a quarter sine u du. Integrate. Which is now going to be minus a quarter cos u, which will be minus a quarter cos 4x. So I'm willing to bet you left out the minus a quarter. Yeah? And you don't need to, because when you put it into this box here, you don't need the plus c yet, so I won't put it in. Mm-hmm. Scroll down. Or scroll back. So it's minus a quarter cos 4x. So let's go back here. It's minus cos 4x over 4. So if you were to think of a rule for integrating sine 5x, then it would be minus cos 5x over 5. You can kind of guess how it's going to work. Yeah? And that's fine in the exam. If you can see that straight away, that's fine. Okay, so our rule is this will now equal fg minus f derivative g, which is another minus cos 4x over 4. So this will be minus 3/4 x cos 4x plus 3/4 cos 4x dx, which is minus 3/4 cos 4x. So can you see what the cos 4x would integrate to? Yeah, what would it be? Cos 4x would become sine 4x over 4. You're dividing by the 4. So it would be minus 3/4 x cos 4x plus 3 over 16 sine 4x plus c at the end. These 4's multiply. And I'll go back to this in a second, but just so I can give you the idea, if I ask you to integrate cos 100x dx, you kind of figured out what's happening. It'll become sine 100x over 100. So as a rule, let's imagine you had cos ax dx. What would that become? It'd be sine ax over a. Now this is not in the formula book. The only thing that's in the formula book is this one, cos x and sine x, not ax. Now what do you want to see? I'm going to go back to the centre in a minute. These are in the book. These ones are not. You can use these in the exam if you remember them. Yeah. Can I go back to the main question? Okay, do you have this? There's another by parts or no? Okay. Which one on volume are we going to have a look at? Yeah. Difficult? Can I do the next one, Marcelo? Yeah. Page 74, number 9. Have a read and then I'll do it. We have a look at it now. So what you have here in number 9 is you have a sine curve. Oh, that's your key, isn't it? Yeah. You have a sine curve and you rotate it. What type of shape would you make if you did that? You know, something.
2 cones.
No, not 2 cones. It'd be almost like 2 eggs. Yes. She'd be in trouble. Yes, typical. Right, so if you rotate this, you make like 2 eggs. And we want to calculate the volume. What's this point? Well, that's 0. But what's this one on the sine graph? Where does it finish? Do you remember? It finishes at 2 pi. Yeah, remember that from semester 1? So let's calculate the volume. The volume will equal pi integrate 0 to 2 pi sine squared x dx, because y equals sine x. Scroll down. So what way did you try to do this? Okay, this is as far as you got, was it? Anyone else try it? Victor, can I go down? Yeah. So, I think what you should do here, you can try to break this into sine x dx, and use the by parts formula. This is f and this is g derivative. So if we have our table now, this would be sine x, this would be cos x. This would be sine x, and this would be minus cos x. Okay, so our formula says this will equal pi f g minus integrate f derivative times g. And there's another minus there as well. Yeah. Okay. Continuing. So volume will equal pi minus sine x cos x plus integrate cos squared x dx, 0 to 2 pi. So what do you think we could do next? Any ideas? Any ideas? No? But we still have this integration to do. Shall we use the rule again? We could. But there's a little trick here. What is cos squared in terms of sine squared? How could you write cos squared in terms of sine squared? What would it be? Cos squared equals... Not quite that. Do you remember this from semester 1? Sine squared x plus cos squared x equals 1. So what does cos squared x equal? 1 minus sine squared x. So that's what I'll use now. Now, by the way, you don't have to do this. You said use the rule again, and you could have done that. But I know that when I use the rule again, all that happens is my cos squared becomes a sine squared again. It's going to keep switching between the two. So if you did the rule, you would have the same result. Your cos squared would become a sine squared. So I'm going to just change it directly using my trigonometry formula. This will now be 1 minus sine squared, 0 to pi. So I get volume is pi minus sine x cos x plus integrate 1 dx minus integrate sine squared dx 0, 2 pi. I just split this now into two separate problems. Yeah? Oh yeah, my x fell off. I split this into two. What's the integration of 1? It's x. Plus x minus integrate sine squared dx. Okay, let's multiply in. So I can put the pi in. And I can put the limits on. I can put the pi in, and I can put the limits on. And I can put the pi in, and I can put the limits on. Let me scroll up a bit so you can see it. Got that? Anybody can spot what this is? It's the same as what we had at the start, isn't it? If I go all the way back to the start, volume is equal to this, which is what I have again down the bottom. So this here is B, and this here is B. I'll put this in on my calculator in a moment. Minus B. I'll make these. Minus B. So what should I do with my B's? Yep. No, the pi is part of the formula for V. If you go back up here, you can see you need the pi with this to make the V. So there's no pi anymore. Yeah, so on the left you have 2V, and on the right, let's calculate this. This one will be, put in 2 pi, put in 0. So if I put in 2 pi, I'll get 0. If I put in 0, I'll get 0. And then on this one, if I put in 2 pi, I'll get 2 pi squared. And if I put in 0, I'll get 0. So I have 2v equals 2 pi squared. So finally, the volume equals pi squared. Tricky question, for sure.
It's the kind of question that we've done that.
This would be a difficult question on the test. It'd be worth like, 7 or 8 marks. They're not usually, Marcelo, they're not usually as difficult as this. They're a little bit more straightforward than this. But it is possible to get something like this on the test. But it'll be, a bigger question for maybe 7 or 8 marks. Yeah. The example that I did earlier for you, wasn't it? This one here. That would be a very common exam question, like maybe for 4 marks or something. Okay, is there anything else in the book to see? Because what I can do now is, I have here a practice exam question. So what I can do, I can do part A is a little bit too difficult to do. No, I could do part A, B, and C today, and I'll do it on the board. So let's go through this practice exam question. This is the integration question from 2 years ago. Right, so I'll do it in 1 minute. I just want you to read it all first. This side, the one that starts with EX sine X. All I want you to do right now is to read it, that's all. Okay, have you read it? So, tell me what type of problem, in maths it's very important that you can recognize what type of problem it is. So in part A, what type of problem is that? Very good, it's a by parts problem. So let's have a look at that, we'll do it together. EX sine X dx. Do I need to swap or not? Which? Swap it, yeah. So I change it into sine X EX dx. And this one here is f, and this one here is g derivative. So my table looks like this. F derivative, g and g derivative. So f is sine x, derivative is cos x. G derivative is ex, so g is also ex. Actually, so this is what I was talking about. You can see that this question is 4 marks. So this will be a normal by parts question in the exam. Okay, so the rule is this equals fg minus integrate f derivative g. Yes, yep, that's it. So that's f g minus integrate f derivative, which is cos x times g, which is ex. So you've seen something like this before. You have to use the rule again. So one more time. F derivative g and g derivative. F is cos x. Its derivative is minus sine x. G is ex. Its derivative is ex. And vice versa. So this equals sine x ex minus, and we'll use the rule again. F g minus integrate f derivative, which is minus sine x, and g again. So this is the rule again on the second part here. And here it is here. Okay, so what I'll do next is I'll put the minus on the inside. So this equals sine x ex minus cos x ex minus sine x ex dx. And you might think, oh, I need to use the rule again, but I don't, because what is this that I have here? It's the same as what was in the question. Sine x ex dx. It was the original question. So I just take this over to the left, and what do I get? 2 of them, yeah. 2 sine x ex equals sine x EX minus cos X EX plus, well, I won't put the plus C in. So the last thing to do, divide by 2. So that means I get my answer, sin X EX equals, I forgot to write dx equals sin X EX over 2 minus cos X EX over 2 plus C. Continue? Yeah. Okay, next one. 1 to 4, x plus 2, 4 minus x power a half dx. Yeah, no problem. To here, is it? What type of problem is the next one, part B? Yeah. Continue? Yeah. And what's nice about B here? They give you the u. Yeah. So what does du dx equal? Minus 1. So dx equals minus du. So we can put that and that back in. So this becomes 1 4 x plus 2. What does this become? U. And what does this one become? D minus du. So I'll put the minus out here. So I replace the dx with minus du, and I also replace the 4 minus x with u. Okay, now what's the problem here? The problem here is it's mixed with x and u. This is a problem. So we need to fix which part, the u or the x? The x needs to be fixed. So if you look here, what does x equal? 4 minus u, if you rearrange it. So that's how you can fix it. This now becomes minus, and I can replace the x here with 4 minus u. So now I get 4 minus u plus 2 u power a half du. Say again? Oh yeah. I'll put them in at the end. Yeah, there are limits here, you're right, yeah. So minus integrate 6 minus u times u power a half du. Okay. Now, what should I do next here? Any ideas? Should I do anything to simplify it? I think I should multiply it. So this will become 6u a half, and this, what's this power here? 1. So when you multiply, what happens to the powers? They add. So this will be 1 plus a half, 3 over 2 is this power. Also, I'll put the minus inside. So the minus and the minus makes a plus. So it'll look like this now. Now I can integrate. What's the rule here? What's the rule? Add 1 to the power and divide by the new power. So this one here, what's the power now? Yeah, 5 over 2 over 5 over 2, and this one 3 over 2 over 3 over 2. Now, do you put the limits in here? Not yet. Why not? What's the problem with this? Yeah. Why should I not put 1 and 4 into this? Well, if you remember, 1 and 4 was for x. it was actually x equals 1 to x equals 4. Is this x? No. So we have to replace the u. Well, we know what the u is. What was it? So it was 4 minus x. So this will be 4 minus x over 5 over 2 power 5 over 2 minus 6 4 minus x power 3 over 2 over 3 over 2. Now we can finish by putting the limits in. Okay, let's put the 4 in first and then we'll put the 1 in second. So 4 can go in first and then the 1 can go in second. So if I put 4 in here, I get a 0. Wait, do I get a 0 for both? Great, 0 minus 0, that's easy. And if I put a 1 in, 4 minus 1 is 3. So it's 3 power 5 over 2 over 5 over 2 minus 6 times 4 minus 1 is 3 power 3 over 2 over 3 over 2. I don't have a calculator, so I don't know what that is. You're typing this in, Lisa? Anyways, I don't have a calculator, but you have it there, Victor? What is it? Huh? Minus. Really? Oh, no, I'm just surprised that the answer was so neat. Okay, 27 over 5. Yeah. See part now? Okay, so what type of problem is in part C? Volume. So volume equals pi. And can you see on the graph what are the limits? Where do we start and where do we finish? 0 to 2. And the function is 4 over 7 minus 3x squared dx. Yeah? So let's square that. We have on the top 16 and on the bottom, I'll keep it like this for the moment. I'm going to take the 16 out. So 16 pi 0 to 2 1 over 7 minus 3x squared dx. So I just took the 16 out. Now I'm just going to put the fraction up the top like this. 7 minus 3x power minus 2 dx. Yes, yes it is. Newsflash, it rains in Ireland.
What's summer?
Irrelevant. Totally irrelevant. Okay, now any ideas on what we can do next to integrate this? Any bright ideas? What would you substitute here? Yeah, let u equal 7 minus 3x. So du dx equals minus 3. So du, sorry, I want to write the other way. Yeah, no, du, no, sorry. Yes, du over minus 3 equals dx. So we can use these two results now. This becomes 16 pi, 0 to 2, u minus 2, du over minus 3. This equals minus 16 over 3 pi, u minus 2 du. Yes? Okay, continue. Yeah. So, what rule do I have here now, or what do I do now? Integrate this. Increase the power by 1 and divide by the new power. I know there's limits here as well. I'll put them in a second. So this will now be 16 over 3 pi 1 over u, because it's u minus 1. And the limits, I shouldn't use them yet because it's u and not x. What did we say the 7 minus 3x, wasn't it? Yeah. 1 over 7 minus 3x, and the limits were 0 to 2. Okay, now let's put in the limits. So first I'll put in 2, and then I'll put in 0. So if I put in 2, 7 minus 6 is 1. And then if I put in 0, it's 7 minus 0, so that's 7. So this will be 16 over 3 pi times 6 over 7. 3 goes into that twice. 32 over 7 pi is what I got. And they want you to leave the answer like this. So the marking is interesting, 4, 6 and 5 marks. Okay, I think that's it actually. Yeah. Next week, if you're wondering, I'm going to do some more calculus. Maybe I'll do some differentiation, product quotient and chain rule revision. And also, I think it'll be good if we also look at some stuff from semester 1 as well. Yeah. Okay. Good. Well, that's good though, because it's going to be half of your final exam.